So welcome back. So the next step in reading the 12 lead ECG is to interpret the axis. So let's talk a little bit about that. Okay, so to begin the discussion, I'm going to remind you of this diagram where you have a negative electrode and a positive electrode. All right, and you have a line perpendicular to the direction of current flow, right? So what we're saying is, if an electrical impulse is going in the direction of the positive electrode, you're going to get a positive wave on the ECG. If it's going in the opposite direction to the positive electrode, you'll get a negative wave. All right, and if it's going in the direction of the positive electrode but at an angle such as this, you'll get a predominantly positive wave. All right, or a smaller wave but still positive. Likewise, if it's going away from the negative electrode, from the positive electrode, but at an angle, you'll get the reverse. So a predominantly negative wave, or a negative wave that's just smaller than if the force was going directly away from the positive electrode. And finally, if the electrical impulse is going directly perpendicular to the electrode, you'll either get a perfectly biphasic wave or you'll get an isoelectric waveform. All right. So that being said, there are 4 basic cardiac axes, which we will represent with this diagram, this quadrant diagram, right? So utilizing lead 1 and lead AVF. Now, I'm going to preface this discussion by saying that determination of the cardiac axis can get a bit more complicated than this, but this basic interpretation of axis is sufficient for most ECGs, especially for the beginner. But it can get a bit more complicated than this, and you can use other leads to assist in your interrogation of the cardiac axis. And also, what I need to clarify is that when we speak about the axis of the heart, we're speaking about the mean electrical vector of the ventricles. So this is the heart. All right, the chambers. What we're saying is we're going to be focusing on the electrical impulses of the ventricles and what is the mean. So when all of those impulses are summated, what is the average direction of that force, right? So in prior ECG videos, we would have mentioned that the mean electrical vector is approximately 60 degrees, right? Anyhow, so let's get back to this quadrant diagram. So using lead 1 and lead AVF, we have 4 possible cardiac axes. You have normal, you have left axis deviation. So what we're saying is the mean vector is no longer going this way, it's going for whatever reason it's going that way. All right, so you have normal, left axis deviation, right axis deviation, and far right axis deviation, also called no man's land. All right, also called extreme right axis deviation. So remember from the diagrams of the electrode placement and how the leads are formed, right? For lead 1, the negative would be on the right arm and the positive electrode would be on the left arm. So you can see why this side would be left and this side would be right. Okay, all right, so let's break this down a bit. So we're gonna speak about the actual science behind it in a basic way, and then we're gonna speak about shortcuts, right? So for example, for an ECG to have a normal axis, right, what we're saying is the electrical impulse is going towards the left and also downwards, right? And we're saying in lead 1, the positive electrode, right, the positive electrode records upright. It will record an upright wave if the electrical impulse is coming towards it, which means going towards the left. And in AVF, the positive electrode will record a positive waveform if the electrical impulse is coming towards it, meaning going down to the foot. So for example, right, let's draw Ralph again. So this is Ralph, this is his heart, and the electrical impulse, which is a normal one, is going like that, right? This is his lead 1. Okay, lead 1, and lead AVF, as we mentioned before, it's a unipolar lead, so let's just put a positive here, right? We don't have to draw all the other electrodes. So this is AVF. So what we're saying is, as you can see, the impulse is going towards the left hand side, so lead 1 should record as positive, and it's also going downwards, right? So AVF will also record as positive. Now, based on the diagrams we drew before, you may have a waveform like this, or you could also have a waveform like this, right? Because of the fact that this impulse is going at an angle, so it's not going directly towards lead 1, even though it is going to the left, and it's not going directly towards AVF, even though it is going downwards, right? It's going at an angle. So you may get a waveform like this, which is just a smaller waveform compared to if it was going straight towards lead 1, or you may get a biphasic waveform that is more positive than negative. All right, so when we say the heart has a normal axis, which is right here, what we're saying is that it's going towards the left and it's also going downwards, like right here, and that is normal. So based on that, we can conclude, looking back at this diagram, that for example, if you have a right axis deviation, that means the impulse is going towards the right and going downwards. So it's going away from lead 1 and it's going downwards towards AVF, like that. Likewise, if you have a left axis deviation, it means the impulse is going towards the left side but upwards. So it's going towards lead 1 but away from lead AVF, like that. And finally, if an impulse, right, is going towards extreme right axis deviation, it will be going out both away from lead 1 and away from AVF, like this, right? And to summarize again, if an impulse is going towards lead 1, you'll get a positive wave, and if it's going away from lead 1, you'll get a negative wave, right? If it's going towards AVF, you'll get a positive wave, and if it's going away from AVF, you'll get a negative wave, right? So we can look at an ECG, for example. So let us say, all right, so let's say this is lead 1 and this is AVF, right? And the QRS complexes in lead 1 are, for example, looking like this, and the QRS complexes in AVF, for example, are looking like this. And I can say to myself, this impulse is going towards the left or towards lead 1, and it's going away from AVF. So I draw my diagram, lead 1, AVF, and I say it's going towards lead 1. So it's got to be somewhere on this side. And it's going away from AVF. So it's got to be somewhere up here. So this is where it intersects. And therefore, this is left axis deviation. Okay, let's do another example. So I could draw lead 1. Okay, let's draw lead 1 like that. And AVF like that. So I draw my diagram again. AVF, lead 1. And lead 1 is saying here, because it's predominantly negative, that this impulse is going away from lead 1. So it's not going towards the left, it's actually going towards the right. So it's somewhere over here. And for AVF, the impulse is going towards AVF or going downwards. So it's somewhere down here. So this is where it intersects. So therefore, this is right axis deviation. Great. I hope I made this topic that for some persons is complicated, somewhat simple. And I'm going to make it even more simple now. Okay. So, let's draw this diagram again. AVF. And lead 1. Now imagine now that these are hands, right? So and there's a head here, all right? So this is the left hand. So lead 1 represents the left hand, and AVF represents the right hand. All right, what we're saying is that if the left hand has a thumbs up and the right hand has a thumbs up, that's normal. Cool. And then furthermore, if one hand has a thumbs up and the other hand has a thumbs down, then the impulse is always going in the direction of the thumbs up. So for example, what if the left hand has a thumbs up but the right hand has a thumbs down? Then it's left axis deviation. If the left hand has a thumbs down and the right hand has a thumbs up, then it's right axis deviation. And if both hands have a thumbs down, then it's clearly very weird. So it's got to be far right axis deviation. So you can use your actual thumbs, look at an ECG and work it out. So let's do that together. All right. So we're going to draw a few examples again. So lead 1 and lead AVF. And we're going to have example number 1, example number 2, example number 3. Let's just draw some random stuff, right? So for number 1, right, your left hand is lead 1. Whoops, a little bit of dyslexia there. Okay, left hand, right, and AVF is your right hand. So in lead 1, it's upright, so that's a thumbs up for my left hand. And in AVF, it's upright, so that's a thumbs up for my right hand. So this has got to be normal, right? 2 thumbs up is good. You're A-OK. That's normal, right? Okay, let's look at example 2. Oh, so let's write normal. Normal axis. All right, so let's look at example number 2. My left hand, right, is a thumbs up. So you can put your hand up. And my right hand is a thumbs down. So that means I can ignore my right hand and it's got to be going in the direction of my left hand. So that's left axis deviation. All right. And then let's look at example number 3. So put your thumbs up. My left thumb is going down, right? Oops, I drew that wrong. So my left thumb is going down and my right thumb is going up. So I can ignore my left thumb, right? We ignore the negativity and we're going in the direction of my right thumb. So that's right axis deviation. And there you go. So you can just look at ECGs, use your thumbs, and you can know what axis we're working with. So now we're going to go through a few examples of real ECGs.